Dear students, so in operations research, how to solve a linear programming problem, that is LPP, using graphical method. Let us discuss in this video. So here I have considered this problem. To maximize z is equal to 3x1 plus 2x2 subject to the constraints minus 2x1 plus x2 less than or equal to 1, x1 less than or equal to 2, x1 plus x2 less than or equal to 3, and the non-negativity constraints x1 and x2 should be greater than or equal to 0. So here there are two variables, x1 and x2 are the decision variables, because these two variables will decide the objective function value z. Okay. So in graphical approach, it is required to represent all the constraints in the graph. Okay, but we cannot directly represent a inequality in the graph because the constraints are in the form of inequality functions. We can represent a line equation if the same inequality, if it is in this format, that is minus 2x1 plus x2 is equal to 1. So this function can be represented in graph because it is a line equation. Okay, it is a linear equation which represents a line. So this can be represented in graph directly. This. So the ideology is, if we draw this line in the graph, then this line and the portion below this line can be considered to be this inequality, because less than or equal to symbol is there in this inequality. So to represent this, if we draw this line, then the line and the portion below this line, that is less than or equal to, can be considered to be this inequality. So this is the ideology. So we are in need of drawing three lines for this problem. So for drawing the first line, that is minus 2x1 plus x2 is equal to 1. To draw any line in the graph, we need at least any 2 points. Okay. So for getting the first point for this line, put x1 equal to 0. So x2 will be 1. Then for getting the second point, put x2 equal to 0, then x1 will be minus 1 by 2. Okay. So using these points we can locate the line in the graph. Then the second inequality, x1 is equal to 2. This line can be directly drawn in the graph. Then the third line, that is x1 plus x2 is equal to 3. Okay. So put x1 equal to 0, we will get x2 as 3, and put x2 equal to 0, we will get x1 as 3. So using these results we can directly draw the three lines in the graph, and we can proceed the problem with this. Okay. So in the graph, consider the decision variable x1 along the x-axis and consider the decision variable x2 along the y-axis. Okay. So we know that the x1 axis represents the line x2 is equal to 0, and the axis x2 represents the line x1 is equal to 0. Okay. So mark the coordinate positions in the graph like this. So now we can locate the points to draw the required lines. Okay. So for drawing the first line, that is minus 2x1 plus x2 equal to 1, mark the points 0, 1 and minus 1 by 2, 0 in the graph. So this is 0, 1 point. Next, mark the second point, that is minus 1 by 2, 0. So this is the point minus 1 by 2, 0. So join these 2 points to get the required line. So this is the line for the equation minus 2x1 plus x2 is equal to 1. Okay. So next we can draw the line, that is x1 is equal to 2. So this is the line representing the equation x1 is equal to 2. Okay. So next, to draw the third line, that is x1 plus x2 is equal to 3, we have to mark these 3 points in the graph 0, 3 and 3, 0. So this is the point 3, 0 and this is 0, 3. So by joining these 2 points we can get the third line. Okay, so this is the line representing the equation x1 plus x2 is equal to 3. Okay, then for considering the non-negativity constraints, that is x1 is greater than or equal to 0 and x2 is greater than or equal to 0, mark the lines x1 equal to 0 and x2 equal to 0. So this is x1 equal to 0 and this is x2 equal to 0. So now consider all the constraints, that is the first line, that is minus 2x1 plus x2 equal to 1. The solution space is below that line because the given constraint is minus 2x1 plus x2 less than or equal to 1. So the portion below the minus 2x1 plus x2 is equal to 1 line should be considered for the problem. Okay, so the portion below this line should be considered for getting the solution. And the second inequality is x1 is less than or equal to 2. So we have drawn the line x1 equal to 2. The solution space is x1 less than or equal to 2. Okay, so the solution space will be on the left side of the line x1 is equal to 2. Okay, then the third inequality x1 plus x2 less than or equal to 3. So we have drawn the line x1 plus x2 equal to 3. The solution space will be below this line because the solution space is less than or equal to 3. Okay, then the non-negativity constraint x1 is greater than 0. So the solution space will be on the right side of the line x1 is equal to 0, and the last constraint x2 is greater than or equal to 0. So the solution space will be above the x2 is equal to 0 line. So by considering all the constraints we can fix the solution space like this. Okay, so next, for following the graphical approach, the next step is to mark the vertices of the solution space. Okay, so any one of the vertex will give the optimal solution by following the graphical approach. So note down the vertices. So this is A, this can be marked as B, this is C, this is D, and this point is E. Okay, so the coordinate positions for A is 0, 0, B is 2, 0. So C point is the intersection of the two lines x1 plus x2 is equal to 3 and x1 is equal to 2. Okay, so by solving these two equations we can get the coordinate position for this point C, that is 2, 1. The point D is the intersection of the two lines minus 2x1 plus x2 is equal to 1 and x1 plus x2 is equal to 3. So by solving these two equations we can get the coordinate position for this point D as 2 by 3, 7 by 3, and point E is 0, 1. Okay, now check the results, check the solution for these vertex points for the objective function. Okay, so vertex value of Z. So 5 vertices are there. A is 0, 0, B 2, 0, C 2, 1, D 2 by 3, 7 by 3, E is 0, 1. The objective function for the present problem is Z is equal to 3x1 plus 2x2. So check the value of Z for the 5 vertex points. Okay, for a 0 comma 0, the value of z is 3 into 0 plus 2 into 0, which will be 0. For the point b 2 comma 0, the value of z will be 3 into 2 plus 2 into 0, which will be 6. For point c, the value of z will be 8, and for point d, the value is 20 by 3, and for the e point, the value of z will be 2. So we are in need of maximizing the objective function z. So the maximum value we have obtained as 8 for the values of x1 and x2 as 2 comma 1. Therefore the optimal solution is maximum z is equal to 8, and which is obtained for x1 is equal to 2, x2 is equal to 1. So this is the optimal result, and this is the solution for the problem. Thank you.